So today we are starting our next chapter, and that is circular motion. So I generally call circular motion as an extension of Newton's laws of motion, because in this circular motion you will try to understand that using what forces are we able to form a circular motion. So ultimately it has to do with whatever forces are required. Okay. So from Newton's laws of motion, we have an idea that if we know the force on a body, then we can write the translation equation as F barabar ma, where F is the net force, A is the acceleration of the center of mass. Okay. But now we are trying to apply that concept in circular motion. And whenever we study circular motion, we study it in two parts. One is kinematics of circular motion, another is dynamics of circular motion. Okay. So I'm just briefing you that how we will proceed. So one part is basically your kinematics of circular motion, kinematics, and another part is like dynamics. So in dynamics part, we study about the forces which are helpful in creating circular motion. Okay. We study about forces useful in creating circular motion. And in kinematics, what we do, we try to find out the relation between the angular variables. क्योंकि देखो जब kinematics हम straight line पे पढ़ते थे तो v बराबर u plus at, s बराबर u plus at plus half at square, तो वो सारे लीनियर वेरिएबल्स थे, उनमें रिलेशन हम निकालते थे. उसी प्रकार से काइनेमेटिक्स में सर्कुलर मोशन की जो काइनेमेटिक्स है, इसमें हम क्या करेंगे, वी ट्राई टू एस्टैब्लिश रिलेशन बिटवीन एंगुलर वेरिएबल्स. टुडे आई विल टीच यू व्हाट आर एंगुलर वेरिएबल्स बेसिकली. ठीक है, तो एंगुलर वेरिएबल्स में हम रिलेशन एस्टैब्लिश करने की कोशिश करते हैं इन अ सर्कुलर मोशन बेसिकली. ओके, that is what the kinematics of circular motion is, and dynamics is study of the motion which are study of the forces which are creating the circular motion. Is my voice loud and clear to you?
Yes, sir.
Okay, now what is a circular motion? First of all, let us understand and just classify what a circular motion is basically. So circular motion, first of all, it's a two-dimensional motion in a plane. It's a two-dimensional motion. So I am writing the attributes of the circular motion. It's a two-dimensional motion because it is not in a straight line, and it is motion in a plane. Motion in a plane. Now, what is a circle basically? Circle is the trajectory of a point which is at a fixed distance from a given point, and that fixed point is called center. Now, what does this path look like actually? So circle is the locus. Circle is the locus obtained when different points on a path are at a fixed distance from the given center. From the given center. So what does this mean? This means basically we have take a fixed point. Let's say it is O. Now all the points on the path are at a fixed distance from this. Then this path is basically called circle. You are aware about it. I have already told you, right? So basically
Yes,
this point is at a distance R. This point is at a distance R. This is what a circle is. And this particular plane in which this motion is happening is called plane of circular motion, and this point O is called the center of the circle. This point O is called center of the circle. ये बातें बहुत important है लेकिन बहुत बेसिक बातें हैं, तुम्हें लग रहा होगा क्यों मैं बता रहा हूं, बट सिंस आई एम कवरिंग एवरीथिंग, that's why I'm doing discussing such small things also. And this particular plane in which circular motion is happening is called plane of circular motion. Plane of circular motion. Okay. Now, Arya, can you tell me what is the axis of circular motion? Can you tell me what is the axis of circular motion? Arya, can you tell me what is the axis of the circular motion?
Sir, which passes through the center.
And is perpendicular to the plane. So axis of circular motion क्या होगी? Axis of circular motion will be anything which is like perpendicular to this, perpendicular to the plane of circular motion and passes through the center. That is called the axis. Suppose you have seen a top is there. A top मतलब लट्टू होता है, उसमें एक की लगी होती है, and this top revolves around this. So basically this is your axis, okay? Then you have earth revolving around its axis. So axis is something which is passing through the center of the circle and it is perpendicular to the plane of the circular motion. So axis of circular motion, something which passes through the center and is perpendicular to the plane of circular motion. To the plane of circular motion. बात समझ में आ रही है? So axis of circular motion ये होता है ना? This is what the axis of circular motion is called. Something which passes through the center and is perpendicular to the plane of circular motion. It is called axis of circular motion. Fine. Now these things are clear. Radius clear हो गया. Then if I make it like this, then it becomes a radius vector. This is your radius vector. Radius vector. ठीक है? Now circle is clear to you. Now I will teach you about the angular variables actually. So there are two families. There is one a linear family. Similarly, there is an angular family also. So angular variables are quite connected in a manner as linear variables are. Okay. So इनमें अगर आप एक सिमिलैरिटी देख पाते हो तो आपको याद रखना बड़ा इजी हो जाता है. देखो लीनियर वेरिएबल्स, अब जैसे लीनियर वेरिएबल में s होता है, दिस इज डिस्प्लेसमेंट. Then you have theta over here in angular variable, and this is called angular displacement. Angular displacement. Okay, so s is linear displacement and theta is called angular displacement. Then you have v, which is rate of change of displacement with time, and this is linear velocity. Linear velocity. And here you get omega, which is angular velocity. Now angular velocity is simply rate of change of angular displacement with respect to time. Same as s and v are connected. Only thing is they are angular variables. They are a bit different, but they are connected in the same way as the linear variables. Then you get a, which is linear acceleration. Linear acceleration. And here you get alpha, which is angular acceleration. Now today I will start with theta, I will go to omega, I'll go to alpha. I'll explain you what all they are, what are their units, how they are measured, how their directions are measured. These are also vector quantities. These are also vector quantities. But the difference is these angular variables are basically axial vectors. I will tell you what they are actually. Axial vectors, their direction is along the axis of the circle. Their direction is along the axis of the circle actually. They are axial vectors. And इनकी डायरेक्शन तो हम ऑलरेडी जानते ही हैं, बट इनकी डायरेक्शन थोड़ी सी अलग तरीके से आती है. कैसे आती है वो सब मैं समझाऊंगा तुमको. तो हमें क्या क्या पढ़ना है, हमें पढ़ना है इनमें आपस में क्या रिलेशन होता है. एंड नेक्स्ट we will also understand that how angular variables and linear variables are connected together. This is also something that we will try to understand, that what is the connection between the angular and the linear variables. So how they are connected together. How can we connect linear variable to angular variable? That is something that we have to take into account. इतनी बात समझ में आ रही है तुमको? अब मैं स्टार्ट करूंगा थीटा से, समझाऊंगा ओमेगा, फिर अल्फा एंड ऑल लाइक दिस. अंडरस्टूड?
यस सर.
ओके, थोड़ा बहुत आइडिया है क्या आपको?
यस सर, थोड़ा
एनी
बहुत.
आइडिया? थोड़ा बहुत है, कोई बात नहीं. आई विल स्टार्ट फ्रॉम वेरी बेसिक, सो डोंट वरी अबाउट. ओके, सो नाउ आई एम स्टार्टिंग विद एंगुलर वेरिएबल, एंड फर्स्ट एंगुलर वेरिएबल इज एंगुलर डिस्प्लेसमेंट. एंगुलर डिस्प्लेसमेंट. तो बेसिकली अगर मैं इसको बहुत सिंपल भाषा में बोलूं तो कितना एंगल घूमा, हाउ मच एंगल इट रोटेटेड along with the sense of rotation, clockwise or anti-clockwise, that is angular displacement. As simple as that. ठीक है? फिर भी मैं इसको properly formal language में भी लिख दूंगा, but in the core thing, if you want to understand what is angular displacement, is how much angle is rotated in a given direction, in a given sense, clockwise or anti-clockwise. This is what the core thing is. अभी समझ में आएगा तुमको. और अगर फॉर्मल लैंग्वेज में बोलूं इसको, तो फॉर्मल लैंग्वेज होगा चेंज इन एंगुलर पोजीशन. जैसे लीनियर डिस्प्लेसमेंट क्या होता था? चेंज इन पोजीशन. आप x बराबर 2 पे हो, x बराबर 5 पे चले गए, तो आपका डिस्प्लेसमेंट क्या आएगा? 5 माइनस 2. सो अगर इसका फॉर्मल डेफिनेशन में बोलूं तो इट इज लाइक चेंज इन एंगुलर पोजीशन. चेंज इन एंगुलर पोजीशन. अगर मैं इसके यूनिट्स की बात करूं तो यूनिट्स विल बी सेम एज like that of the angle. It could be like degree, it could be like radian also, and sometimes we use revolution word also, because one revolution signifies 360 degree. So sometimes we use revolution also. We can say one revolution. How much is the displacement? One revolution. Angular displacement is one revolution. That means it has rotated 360 degree from its initial position. So sometimes rev, or we call it as revolution, is also used as one of its units. Now, the proper way of measuring this angular displacement is basically, let me tell you, suppose I have got a circle like this. Okay, this is a circle given to me, and these are the two straight lines. अब ऐसे समझो कि मेरा कोई एंगल मान लो, I was here initially. Let me assume that I was here somewhere initially. ये एंगल 30 डिग्री है. So theta initial is basically 30 degree. And then what I did, I rotated and I went somewhere over here. I went somewhere over here. And this came out to be again 30 degree, let's say. And this is my final position, theta final. Now, if somebody asks you what is the angular displacement, can you tell me? Can you tell me what is the angular displacement? This angle basically. This is what our angular displacement is. Okay. Can you tell me what is the angular displacement? Arya, are you listening to me?
Yes,
Arya?
sir.
So my angular displacement is how much? Can you tell me?
Sir, 210 degrees.
Anti-clockwise. Perfect. 210 degrees anti-clockwise. बिल्कुल सही है. We measure angles from here. This is our initial angle, and the final angle will be like this, which is like final angle is like this, which is like 240 degrees. Now 240 degrees is our final angle. 30 degrees is our initial angle. So angular displacement comes out to be 210 degrees. Anti-clockwise, because I have moved like this. So this is what the angular displacement is right now. Are you getting my point?
सर
From initial position to final. हाँ बोलो.
सर हमने इस साइड से क्यों नहीं लिया एंगल?
एंगल हमेशा एंटी क्लॉकवाइज मेजर होता है. अभी मैं बता रहा हूँ वो सब चीजें. सो एंगल इज ऑलवेज measured in एंटी क्लॉकवाइज सेंस. आपने फर्स्ट सेकंड थर्ड क्वाड्रेंट का कंसेप्ट सुना है? तो यू गेट दिस एज फर्स्ट, दिस एज सेकंड, राइट? सो इट गोज लाइक दिस. Angle is always measured in anti-clockwise sense, starting from positive x-axis. This is your positive x-axis. Starting from positive x-axis. बात समझ में आ रही है तुमको?
यस सर.
अब अगर मैं तुमसे बोलूं, लेट्स से अगर मैं तुमसे बोलूं कुछ ऐसा कि मेरे पास यहां पर ऐसा कुछ ये दे रखा है ना, यहाँ x है और यहाँ y है. लेट्स से मैं यहां से स्टार्ट हुआ है ना, आई स्टार्टेड फ्रॉम हियर, आई रोटेटेड लाइक दिस एंड आई केम टू दिस प्लेस. Starting point was this. Okay. So can you tell me what the angular displacement is? Can you tell me, Arya?
सर 90 degrees.
No. Right now, the angular displacement is, see, your theta final is basically, it's like 360 plus 90. It is not 90. It is not linear thing, no. It is how much angle you rotated in the same sense, actually. You are rotating in the same sense. So it is not, it will not get subtracted, actually. This is a major confusion what children are having. So here angular displacement is 360 plus 90.
Okay, sir.
Okay, so this is the major confusion because and it is in the anti-clockwise direction, ACW. Similarly, if I make two full rounds, suppose I start from here, I go like this, and I again go like this, then you will get angular displacement as 720 degree anti-clockwise. अरे बात समझ में आती है? Because there are two complete rounds. And they are in the same direction. हाँ, अब मैं तुम्हारा डाउट भी क्लियर करता हूं. देखो, अगर if you started from here, this be your starting point, you went like this, ठीक है? You went like this be your starting point, and Afterwards, in your second round, you again started from here and you went like this. This is your second round. Then your angular displacement will be 0. Understood क्या? पहले तुम ऐसे गए फर्स्ट राउंड में, यहां तक आए. Okay. And then you started back and moved like this. Now your angular displacement कैसे निकालोगे? निकालोगे 360 डिग्री एंटी क्लॉकवाइज प्लस 360 डिग्री क्लॉकवाइज, and this comes out to be 0. Angular displacement comes out to be 0. Are you getting my point?
Yes, sir.
तो ऐसे करना है बेटा, ठीक है. अब ये जो डायरेक्शन होती है, the direction of the displacement can be ACW clockwise, and there is one more way to represent the direction actually. That is what I am telling you right now. We know that there are two possible directions. One is anti-clockwise and clockwise are two possible directions of circular motion, but they can be represented in a different way, using right hand rule. Do you know what it is? Suppose a body is performing circular motion like this, about this center. It is going like this. Now, if you look at from the top, you will say that this direction is basically anti-clockwise, right?
Yes.
Are you getting? Now, if I want to define it in another way, what I should do, I should take my right hand, I should curl my fingers along the circle, and the thumb will point out the direction in the top side actually. So if I take my hand, suppose I try to draw a hand, though my drawing is not very good. I try to draw a hand. These are the fingers basically, and they are being curled. Let's say these are the fingers, they are being curled. And so my thumb will point towards the top. Are you getting it? Because I am taking my right hand. This is my thumb of right hand. And I am curling my fingers such that the thumb is pointing. So I can say that if it can also be called as anti-clockwise direction, can be called as along the axis outside the plane. Okay, so this is one more way of calling anti-clockwise direction. So ACW direction is also called as along the axis outside the plane, using right hand rule. And we call this direction as positive direction because it is outside the plane. And it can be represented using this. Are you getting it?
Yes, sir.
So this is how it is. So are you really clear what I'm trying to say?
Yes, sir.
Or I should explain you using the camera in the background?
No,
Like,
sir. Clear.
okay, fine. Perfect. So basically, similarly, if I got a clockwise direction is along the axis inside the plane, along the axis inside the plane, denoted by this, and this is basically negative direction. This is basically negative direction. Are you getting my point?
Yes, sir.
ठीक है बेटा? इतना क्लियर हो गया तेरे को?
हाँ सर।
अब मैं ये समझा रहा था, जैसे यू नो व्हाट इज द रिलेशन बिटवीन डिग्री, रेडियन and revolution? Can you write the relation? One revolution is how much degree? 360 degree. And is equal to how many radian? 2 pi radian. Is it clear to you?
Yes sir.
This is what the relation is actually. So I want you to do few sums for me. Okay, take out your rough copy and pen. Take out your rough copy and pen and do few sums for me. They are like, suppose I have got 45 degrees. I want to express it in terms of revolution as well as radian. Do one thing. Second is like, if I've got 2.5 revolution, I want it is in degrees, I want it in radians. And suppose I have got 3 pi by 2 radians, I want it in degrees, I want it in revolution. Just sort this out, send me, let us check. And this is the core thing that you have to remember. Are you doing it?
Yes sir.
Okay, good. Okay, let's verify. So 45 degrees basically 360 degrees one revolution. Na? So 45 degrees 1 by 8th part basically. 90 degrees 1/4 part, which is very true. This is 1 by 8th of the revolution. Very correct. And it is 90 degrees pi by 2 radians, so 45 degrees pi by 4 radians. Perfect. Then you have got 2.5 revolutions. One revolution is 360 degrees, so 2.5 will be simply 360 multiplied by 2.5, which is 720 plus 180, and it is like 900 degrees. No doubt about that. Perfectly all right. In terms of radiation, if we radian, if we do, one revolution is 2 pi, so it is like 2 pi plus 2 pi plus pi, because it is 2.5 revolution, and it is perfectly given as 5 pi radians, no doubt. 3 pi by 2 degrees, 3 pi by 2 radian basically. So 1 radian, 2 pi radian is 360 degrees. So 1 radian is basically 360 upon 2 pi. 3 pi by 2 is 360 upon 2 pi into 3 pi by 2. Pi se pi cancel ho jayega. And it comes out to be 270 degrees. No doubt about it. And definitely 2 pi radian is 1 revolution. So 3 pi by 2 radian is basically 3 by 4th of a revolution. No doubt. Perfect. That is all correct. So are you comfortable with angular displacement now? Are you comfortable?
Yes, sir.
Okay, okay. This was a very important example. Keep in mind, uh, if there is angular displacement in the same sense, there are 4 rounds, then it doesn't become zero. It becomes zero when the sense once is clockwise, another time it is anti-clockwise. Then only it becomes zero. Otherwise, in the same sense, it adds up. Okay. So this is all about angular displacement. It is represented by theta. Units are clear, directions are clear, right hand rule is clear to you. Fine. Now let us come to angular velocity. Okay, and it is represented by omega. Let us come to angular velocity. This is another angular variable. Angular velocity represented by omega. This we pronounce it as omega. This we don't call it as W, we call it as omega. And now on the similar lines of linear velocity, you can define angular velocity. It is rate of change of angular displacement with respect to time. With respect to time. Is it okay, Arya? In the same way, we used to define linear velocity, rate of change of displacement with respect to time. Similarly, omega can be defined like that. Are you okay with this?
Yes, sir.
Okay. Now, if you remember, while defining velocity, we have like two of its forms. One is like average velocity and one is like instantaneous velocity. Do you remember that?
Yes, sir.
In the similar format, you will also get angular average velocity and instantaneous velocity. Both the things you will get in the similar format actually. Like you got it for linear velocity, you will get average and instantaneous for this as well. Okay, so what will happen is basically this is the basic definition. Then I have two formats. One is like omega average. It is defined as del theta by del t. Theta final minus theta initial upon t final minus t initial. This is average angular velocity. Average angular velocity. ठीक है बेटा? There is one more omega, which is omega instantaneous, and it is defined as d theta by dt. Is it okay?
Yes, sir.
This is your instantaneous angular velocity. Instantaneous angular velocity. Everything is going in the similar format, no doubt about it. Then comes the unit part. Now, yeah, really, the units are really important. Can you guess the units for omega actually? Can you guess what the units will be like?
Sir, degree per second.
Okay, it could be like degree per second, or it could be like radian per second. Okay, right?
Yes,
Because
sir.
angle can also be measured in radian, no?
Yes, sir.
And it could be like revolution per second also. Okay. So there can be several possible units actually, but what are the main units that are mainly used? One is like radian per second can be a unit, degree per second can be a unit, revolution per second can be a unit. Okay. Then you have radian per minute can be a unit, degree per minute can be a unit, and revolution per minute can be a unit, and it is usually called RPM. If you have heard of it, sometimes the mechanics they talk about how much RPM is this motor is. Have you ever heard of it?
Yes, sir.
So, and further going by, you can get radian per hour, but that is not usually used. What are the usual used units? One is radian per second, and one is this revolution per minute. These are the usual used units actually you have got. Radian per second भी usually use होता है, revolution per minute भी use होता है. These are the usual units you use. And it's very simple to make. You know what is the unit of theta? It is radian. Okay. What is the unit of time? It is second. So it is radian by second. That's all. Is it okay? Next, talking about the direction. Then again, you have like two directions. One is like anti-clockwise. It is taken as positive. It is outside the plane of paper. Outside the plane of paper. And then you have like clockwise, which is negative. It is inside the plane of paper. Same as that of theta. Is it okay?
Yes, sir.
Okay. Now I will give you few questions actually that you need to let me know how these questions are being formed. Okay. So let's say there's a question. Let's say I have a particle. Okay, sorry. I'll try to make a nice circle for you. Just a minute. Give me a second. Let's say I've got a particle over here initially. Initially, the particle is here. And after that, the particle comes here. So initially, particle is at 30°. Okay. And this is the initial position. And this is the final position actually. Now, how the particle came here? I'm telling you this. See, the particle simply came like this, in this sense. Understood? It was at t barabar 0, the particle was here. T barabar 5, the particle was here. 5 seconds. Now, simply it is being asked, find out omega average. Can you find this out? Along with the direction and sign, find out omega average. Are you doing it? Acha, have you sent me? You can tell me the answer here itself. Are you listening to me?
Yes, sir.
Can you tell me the answer here itself?
Sir, minus 60.
Perfect. It will be like 60. No, but minus 60 is the angular displacement, no? Divided by time will also come. Minus 60 degree, and it is 5 seconds. So answer comes out to be minus 12 degree per second. Are you getting it?
Sir, I have done differently.
You have done differently,
Yes, sir.
but the formula is same, na? Omega average is del theta by del t. You have not put del t at the bottom.
Sir, I got 300 degrees upon 5.
No. You have taken in a wrong way, na? The angular displacement is like this, na? It has
Yes,
not gone
sir.
like this actually. It has not gone like this actually. You have taken it in the anti-clockwise sense.
Yes, sir.
Whenever you consider angular displacement beta, it is very important to take the sense. I have given you the sense is clockwise. So the angular displacement cannot be taken as 300 degree. It is minus 60 degree.
Okay,
Understood?
sir. Yes, sir.
Yeah. So अगर मैं तुमको बोलता ना कि it has gone like this, then you could have taken it as 300 degree, and the answer would have been 300 upon 5. Understood?
Yes, sir.
Okay. One more question. Do this question. There's one more question. It is given to me as theta is equals to 2t square minus 3t plus 2. So there are two parts to this question. Find omega average between t equal to 0 and t equal to 5 seconds. And B part is find omega instantaneous at t बराबर 3 सेकेंड. These are the two parts. Solve it.
Sir,
Yes.
sir, can I tell the answer or send it?
Yeah. You can tell me the answer.
Sir, 35 degree upon 5.
Okay. You have taken this theta in degree. Let it take in radian only. So it will be 35 radian upon 5 in
Yes,
the first
sir.
case. So basically, you might have done t equal to 5 पे theta निकाला होगा in A part.
Sir.
You have gone like this, omega average as theta at t equal to 5, which is like 50 minus 15 plus 2. Theta final minus theta initial is 2 upon delta t is like 5. Okay, this is how you proceeded. 2 minus 2 0 हो गया. 50 minus 15 कितना होगा? 35 by 5, 7. So answer comes out to be 7 radian per second. Right? है ना बेटा?
Yes, sir.
ओके. बी पार्ट क्या आ रहा है आपका?
Sir, 9 degree per second. 9 rad per second. Radian.
Okay, so it comes out to be like 4t minus 3, and t is placed as fine, perfect, 9 radian per second. This is a perfect answer for the B part. So is this thing clear to you? How is omega defined? What is the direction and all? Everything is okay?
Yes, sir.
Fine. So direction is also clear to you. Now we come to like angular acceleration, which is alpha. Okay, we are done with angular velocity. Now we come to angular acceleration. Angular acceleration, it is alpha. So let us discuss about its attributes. What possibly it could be? It is responsible for changing omega, a very important thing, है ना? It is responsible for changing omega, because acceleration is responsible for changing velocity. In the similar manner, alpha is responsible for changing omega, and it is defined as rate of change of angular velocity omega, with respect to time. This is how it is defined as rate of change of omega with respect to time. Are you getting it? So based on this, alpha can be defined as d omega by dt. Is it okay? There could be two other formulas also. You remember three formulas for acceleration? You remember three formulas for acceleration? Aryan, one is dv by dt, one is v dv by ds, and next is d2s by dt square.
Yes, sir.
Similarly, here instead of s you get theta, instead of v you get omega, and instead of a you get alpha. P तो अपनी जगह रहेगा ही. So similarly, this can be d omega by dt. It can be omega d omega by d theta. Because I am trying to remember these formulas, like a is equals to dv by dt is one thing, v dv by ds is another thing, and d2s by dt square is another thing. So d omega by dt, omega d omega by d theta, and d2 theta by dt square. This is also the last formula. Are you aware of it? So alpha can be defined in these three possible ways, out of which these are the two important ones. This is rarely used. And now you can very well tell me what the unit of alpha will be. Can you tell me the unit of alpha? Batao.
So degree per second square.
Yeah, it will be like radian per second square. The mostly used units are radian per second square, revolution per minute square. These are the most used units basically. Okay. Mainly we use these units, radian per second square, degree per second square is also okay, no doubt about it. So these are the units basically. And when you talk about the direction, it is the same stuff again. Direction, clockwise, anti-clockwise. Anti-clockwise, positive, outside the plane. Clockwise, negative, inside the plane. These are the directions of alpha. बात समझ में आ रही है? अब अल्फा का काम क्या होता है? ओमेगा को चेंज करना. अभी अब चीजों को ध्यान से सुनना. If alpha is 0, in any case, if alpha is 0, then omega is constant, and that motion is called uniform circular motion. Uniform circular motion. तो अगर अल्फा 0 है तो ओमेगा कांस्टेंट है, एंड दैट मोशन इज कॉल्ड यूनिफॉर्म सर्कुलर मोशन. बट अगर अल्फा नॉन जीरो है तो या तो ओमेगा बढ़ेगा या कम होगा. समझ रहा है क्या? If alpha not equal to 0, then there are two possible cases. Omega will either increase or omega will decrease. This is non-uniform circular motion. Are you getting my point?
Yes, sir.
तो बेसिकली अगर मान ले मेरे पास एक चक्री है, वो घूम रही है और वो 1 मिनट में 2 चक्कर काट रही है. पहले 1 मिनट में भी 2 काटे, दूसरे 1 मिनट में भी 2 काटे, तीसरे 1 मिनट में भी 2 काटे. तो दैट इज यूनिफॉर्म सर्कुलर मोशन. Ultimately, uniform circular motion is signified by constant omega and alpha 0. The number of chakkar per unit second, per unit minute, or per unit hour should not change. That is what uniform circular motion is. If alpha is not equal to 0, then omega will either increase or omega will decrease. Okay, now अल्फा का काम है, अच्छा तेरे को पता है एक्सेलरेशन का काम होता है वेलोसिटी को बढ़ाना, वेलोसिटी को घटाना. मान ले मेरा ओमेगा ऐसा है. अब अगर मैं चाहता हूं ओमेगा बढ़े तो अल्फा भी ऐसा ही आना चाहिए. In this case, omega will increase because angle between, can you tell me angle between alpha and omega is, can you tell me Arya, what is the angle between them?
So 0 degrees.
0 degrees, exactly. They are out of the plane. So acha, it could be reverse also. If omega is clockwise, alpha is clockwise, then also omega will increase in the negative direction will increase. So omega will increase when angle between alpha and omega is 0 degrees. But at the same time, let's say if alpha is like this, okay, and let's say the omega is like this. At this point in time, what will happen? Omega will decrease as the angle between alpha and omega is 180 degrees. Are you getting my point?
Yes, sir.
This is how the things are. समझ में आ गया?
हाँ सर.
अच्छा, बहुत बढ़िया. अब alpha will determine whether the omega will increase or not. Like these are the things. Now let's say if I have been given like this, let's say for example, I'm given a question like omega is equals to theta square minus 2 theta plus 2 radian. Find out alpha as a function of theta. As a function of theta. Do this question. Send me on Telegram after doing it. Which formula will you apply?
Sir, omega
Hmm.
d omega by theta by d theta.
Omega d omega by d theta. Okay, do it and send me.
Sir, I've sent.
टेलीग्राम पे भेजा ना.
Sir.
So perfect. This d omega, if we do d omega by d theta, this comes out to be like 2 theta minus 2, and omega is this. So omega d omega by d theta is basically theta square minus 2 theta plus 2 into 2 theta minus 2. Yes, that is absolutely okay. So this comes out to be 2 theta cube minus 6 theta square plus 8 theta minus 4. Perfect. This is how it will look like. Okay. Next, tell me one more question to me. Let's say omega is equals to 2t square minus 2t plus 3. Find alpha average from t equal to 0 to t equal to 4 seconds. How will you do it?
Sir, substitute t as 0 and 4.
No, what will be the formula you will use? Alpha average as omega
Alpha
final?
average, omega final minus omega initial upon t final minus t initial.
Exactly. Exactly. Now you will do it. कर लोगे तो?
Yes, sir.
ठीक है तो let it be. कर लोगे ना? Don't waste time now. Okay.
Sir.
Now do these conversions for me. These conversions are really very important. Like if I've got 21 RPM, I want to convert it into radian per second. Let's say I have like 60 degree per minute. I want the answer in radian per second. Forty revolution per second. I want the answer in radian per second. And I've got like 3 pi by 2 radian per second. I want the answer in RPM. These are the 4 questions I want the answers. Send me on Telegram once you're done. You could have told me, no, you have already sent it. So 21 RPM, revolution per minute. So the bottom part becomes 60 seconds minute and 21 revolution को radian में करना है. One revolution is 2 pi, so it's 21 into 2 pi. Perfect. 42 pi. 60 degree. 1 degree, 180 degree is pi radian, so 60 degrees pi by 3. And minute gets converted to second, it becomes 60. So here you have made a little mistake, I think.
Yes, sir.
Right? It will be like pi by 180, okay? Okay. Then you have like 40 revolution per second. It will be like second remains in second and revolution gets converted to radian. So it will be like 40 into 2 pi, no doubt. Perfect. Then you have 3 pi by 2 radian per second. So you know 1 radian is basically how you did that. RPM में convert करना है. तो 1 second will be like 1 by 60. 60 goes up, no doubt about it. And how you did radian to revolution, beta?
Sir,
1 revolution is 2 pi, है ना?
yes, sir.
So 2 pi radian is 1 revolution.
Sir, it will
That
be
means
3 pi by 2 by 2 pi.
3 pi by 2 radian will be 3 pi by 2 by 2 pi, and you have written as a 4 pi at the bottom, which is perfectly okay. So it becomes out to be 3 pi by 4 pi, and from second to minute conversion, 1 second will become 60 minutes. Perfect. So are you comfortable with whatever we have done today?
Yes, sir.
So this is good enough for today, and tomorrow we'll proceed further. Okay. Just do revise these things, and I request you to have a look at your frictional lectures. Okay.
Yes, sir.
Okay. Bye.
Thank you, sir.
Okay, beta.